Students, today we are going to start chapter number 6, Triangles. In this chapter, first of all, we will learn congruent figures and similar figures. For example, let us start with the triangle. This is triangle ABC and this is triangle BEF. Now, when these two triangles are called congruent, if and only if angle A is equal to angle D, angle B is equal to angle E, angle F is equal to angle C equal to angle F, and AB is equal to DE. For example, it is 3 centimeter. This must be 3. This is 4. Then this must be 4. Suppose this is 6. Then this must be 6. That means if corresponding angles are equal and corresponding sides are also equal, then we say that triangle ABC is congruent to, this is the symbol of congruent, to triangle DEF. So congruent is clear. Congruent means the photocopy. If I keep this ABC triangle on DEF, it will coincide it. Then they are called congruent. For example, I have taken a circle of radius 3 centimeter. Another circle of also radius 3 centimeter. Then these two triangles are said to be congruent. You can take any polygon. For example, I had taken a pentagon. Regular pentagon of 6 centimeter side. This is also a pentagon with 6. We say that these two pentagons are congruent to each other. So I think congruent figures is clear to everybody. That means, but in this chapter we have to learn about the triangles. So congruent triangles means all the three corresponding angles are equal. That means if A is 30 degree, D is also 30. B is equal to angle D. Angle C is equal to angle F. Then we say that triangle ABC is congruent to triangle DEF. And about this congruency, we had learned in 9th standard. Now in this 10th, we have to learn about the similar figures. What is the meaning of similar figures? Okay, I had taken a triangle ABC. And another triangle I had taken, that is X, Y, Z. Now here, angle A is equal to angle X, angle B is equal to angle Y, angle C is equal to angle Z. That means corresponding angles are equal. But here, the corresponding sides, in congruency, corresponding sides must be equal. But here it's not necessary. But here, what is the condition? Corresponding sides must be in the same proportion. Now, what is the meaning of that I am explaining? That means AB upon XY must be equal to BC upon YZ, must be equal to AC upon XZ. That means this must be a constant. For example, if this is 2, 4, 6, then it must be 1, 2, 3. Because see, here AB upon XY is 2 by 1. BC upon this is also 4 by 2. 4 by 2 means again 2 by 1. And what is AC upon XY? That is 6 by 3. That is also 2 by 1. So all is equal to 2 by 1. So we say that similar triangles means corresponding angles are equal and corresponding sides are in same proportion. So the first condition is corresponding angles must be equal, and the second condition is corresponding sides must be in same proportion or ratio. So I think this concept is clear. Now congruent triangles are also called similar triangles because they are equal. But all similar triangles are not congruent triangles. Now let's talk about the circle. Suppose this is a circle of 3 and this is the circle of 6 centimeter. So all circles are similar. all circles are similar to each other. Similarly, we can talk about the square. All square, because all four sides are always equal in all squares. So all squares are also similar to each other. Again, all equilateral triangle. Equilateral triangle means whose all three sides are same. So all equilateral triangles are similar to each other, because in equilateral triangle all angles are of 60 degree and all the three sides are same. Here also all three sides are same. So all sides will be in the same proportion. So we can say that all circles are similar to each other. All squares are also similar to each other. All equilateral triangles are also similar to each other. Exercise 6.1, question number 1. All circles are dash. Now the question is, all circles are congruent or similar? So the answer is similar. All circles are similar. Why? When they are congruent, if the radius of all circles are same, then we say they are congruent. But here they are not talking that all circles are having the same radius. They are saying all circles are dash. So the answer is similar. Question number 2. All squares are dash. So again, all squares are similar. They are not congruent. When they are called congruent, if all four sides of all they are same. For example, this is 4, 4, 4. This is also 4, 4, 4 and 4. Then we say, okay, these two are congruent. But they are not saying that the corresponding sides are same. Suppose this is 8, 8, 8. So this is also square, this is also square. But these two squares are similar, not congruent. Question number 3. All dash triangles are similar. So which type of triangles are similar? Equilateral, or we can call equiangular also. Equilateral triangles are similar. Now question number 4. In question 4, two polygons of same number of sides are similar if, first, what are the two conditions? If their corresponding angles are equal and their corresponding sides are in same proportion. See, angles must be equal and corresponding sides must be in same proportion. Then we say they are similar. But angles are equal, sides are also equal, then we say they are congruent. So here the answer is proportional. We have to select from the option. So in place of proportional, if ratio is given, then ratio is also the correct answer. So equal angles are equal, corresponding angles are equal, and corresponding sides are in same proportion. Then we say that the two polygons are similar. Now question number 2. Give two different examples of a pair of first similar figures. Okay. So we can say we have to give two examples, all circles, or we can say they are asking for a pair. So let us write two circles, because any two circles are always similar. And let's give another example. So we can say two equilateral triangle, or you can write two squares. All are correct. So two circles are the example of similar figures. Two equilateral triangles, again the example of similar figures. If more are asked, you can say squares, a pair of square. All are the examples of equilateral figures. Now we have to give for non-similar figures. So you can say a triangle and a circle. They are not similar. A triangle and a circle. You can take something else also. For example, a square and a circle or a triangle or any other thing. So these are the example of similar figures, and these two are the examples of non-similar figure. Now question number 3. Question number 3. In this question, they had given two figures. Both are quadrilateral. And you see this is rhombus and this is a square because this is 90 degree. Now here, the ratio, that is the ratio of the side is same. That means here, suppose I am giving the name A, B, C, D. This is A, sorry, not A, D, E, F, G or J, N. Okay, so if I am taking AB upon D, it is 1.5 by 3. So you take any pair of any side, BC upon EF, that is also 1.5 by 3. DC upon GF, that is also 1.5 by 3. AD upon DG, that is also 1.5 by 3. So sides are in same proportion. So can we say they are similar? The answer is no. Why? Because they must satisfy both the condition. What was the first condition? Angles must be equal. That means angle A must be equal to angle D. But here angle A is not 90, D is 90. So here angle A is not equal to angle D. If remaining are equal, but then also not possible. Okay. So here all four corresponding angles must be equal. Here A is not equal to D, so no need to check for any others. So B is not equal to, it is not. So here, so what reason you will write? Corresponding angles are not equal, therefore these two figures are non-similar figures. So they are not similar. Okay, now one more thing. The sign for congruent is like this and the sign for similarity is like this. Okay. Similar triangles. Triangle ABC is similar to triangle XYZ if and only if it satisfies the two conditions. Which are that two conditions? First, corresponding angle must be equal. That means angle A must be equal to angle X, or we say that angle A must be congruent to angle X. If it is 40, it must be 40, like this. Angle B must be congruent to angle Y. Angle C must be congruent to angle Z. That means the measurement of angle A must be equal to the measurement of X. B must be equal to Y, C must be equal to Z. And second condition is the corresponding sides. Which is the corresponding side for AB? XY. Must be equal to the corresponding side BC by YZ must be equal to AC by XZ. It is XZ. Okay. So we say that or you can write ZX. All is correct. Okay. So what is the first condition? Corresponding angles must be congruent and corresponding sides must be in same proportion. If they are equal, then both will become the congruent triangles. If the sides are equal, then. Okay. Now how we will write symbolically? We will write like this. Triangle ABC is similar to triangle XYZ. You can't change the order. Here A is equal to X, so both are coming first. B is equal to Y, so both are in middle. And C is equal to Z, so both are coming last. Suppose I don't want to write A first. I want to write like B, A, C. It is correct, but then I will change this X, Y, Z. B is equal to which angle? Y. So Y will come first. A is equal to X, so what will come? X. And in place of C, what will come? Z. So you can write like this also, both are correct. But here this must be, we can't change this system anytime. Okay, so if you are taking B first, then Y will come first. A, because B is equal to Y. So the corresponding angle for B is Y. So if B is written first, then Y will be like this. Okay, suppose I am writing like this. Triangle CBA for the same figure. Then what will come is similar to triangle. Angle C corresponds to Z. So first Z will come. Then B, Y. And A, so X. So I can say angle C, triangle CBA is similar to triangle ZYX. All three are having the same meaning. But you can't write like this. ABC is similar to triangle ZYX. If you will write like this, then the meaning changes. That means angle A is equal to angle Z. B is equal to angle Y. C is equal to angle X. So always maintain the sequence of this alphabet. All three are having the same meaning and all three are correct. But most probably we always start with the first alphabet. Okay, now in next time we will discuss theorem 6.1. Thank you.